You probably know that Snowflake Cortex is a collection of AI-powered tools that allows you to call large language models, perform document AI, prepare data, and all of this with built-in security and governance. In terms of data preparation, you also know that you could perform translation, summarization, compute sentiment score, and also extract answers from text. And so in this video, I'm going to show you how you could perform all of this in Python using the Modin Dataframe as an example, where you essentially import your data into a Modin Dataframe and then perform Cortex computation right inside the data frame. And so we're going to perform an end-to-end workflow starting from importing the data, processing the data, until writing the data back into the Snowflake database. And then finally, we're going to build a very simple Streamlit application right inside the notebook. And so if this sounds like fun, keep on watching. And without further ado, let's dive in. So in this video, we're going to show you how to use Snowflake Cortex to process the Avalanche product catalog data directly from a Modin Dataframe. So in a nutshell, we're going to cover in an end-to-end fashion the following 7. So first, we're going to load in the Avalanche product catalog data from an S3 bucket into a Snowflake stage, which is kind of like a local storage on Snowflake. And then we're going to read in the CSV data into a Modin Dataframe. Then we're going to perform some data processing using Snowflake Cortex, particularly the pre-built or built-in LM functionalities, which includes classify, translate, sentiment, summarize, and also answer extraction. Once we have done that, we're going to perform some data processing to tidy up the data frame. Afterwards, when all of the data is all prepped and clean, we're going to write it into a Snowflake database table. Finally, we're going to demonstrate you from the data that we have saved, we're going to perform some basic query of the newly created table. And then finally, we're going to build a very simple interactive user interface using Streamlit inside Snowflake notebooks. And so we have a lot to cover here. Let's dive in. So first thing is you want to install some of the prerequisite libraries. And to do that, let's go ahead and click on Packages. And also don't forget that the link to this particular notebook is provided in the video description so that you could download it and then you could upload it into your own Snowflake environment. So as mentioned in this cell, we're going to install Modin, which will allow us to use the data frame, which in turn supports Cortex. And then we're going to have to install the Snowflake ML Python so that we could leverage the Cortex LM functionalities. And we're also going to install Snowflake Snowpark Python, which Modin and other functionalities of Snowflake relies on. And so Python Streamlit here is already mentioned, and it comes pre-built whenever you spin up a new notebook. So once you have selected the packages mentioned, click on Save, and then it should ask you to restart the environment. And so let's go ahead and restart the environment. Since I already have done with the installation of this in a prior session, it has already saved all of the libraries into the environment. So whenever I spin it up the second time, this particular notebook, and then press on Start, it will have all of the dependencies ready for me to use. So super convenient. So I don't have to do this every time I load the notebook, only the first time. All right, now it's active and we're ready to begin. So let's go ahead and load the prerequisite libraries here. And this is for if we need to use the Snowflake session to perform task. All right, and so in the next section here, we're going to load in the data from an S3 bucket and then bring it into Snowflake. So first we're going to create a stage, or if it has already been present, it will override it. And so we're going to call it Avalanche. So the Avalanche stage will be created in the database schema that we specify whenever we create the notebook for the first time. So let's go ahead and run this. You might see that I already have some status from a prior run. So why don't I clear all of the results and let's start fresh. Go ahead and run this. And then this is a confirmation that the stage has been created. Now we're going to list the content of the stage. So it's pretty much like in a command line on the Linux when you type in ls, and then you're going to see the list of files. So ls is like list the files in the stage avalanche. So we have all of these available CSV file from our S3 bucket link. And we're going to load in the product catalog. Let's go ahead and do that. So we're going to load it in using the read CSV method. PD here is from the Modin Dataframe, where we have import Modin as PD. So when you read in the CSV data, you should be able to see the following 3 data columns: name, description, and also the price right here. So this is based on a winter sports gear company, a hypothetical one. So here are the product lines. So we have a total of 10 products, accompanying with the description and also the price. Let's proceed further. All right, so for this particular very simple data frame, we're going to perform some processing. And we're going to use Snowflake Cortex. So if you have already used it before, you'll know that it's a very powerful AI and ML tool or suite of tools that will allow you to leverage your Snowflake data cloud to its maximal capabilities using LLMs. So it is able to handle both data and images, so more or less like multimodal capabilities. So here we're going to perform some of the data or text LLM functionalities. So let's go ahead and use the classify function. So we are to use that in a Modin Dataframe. So for those of you who are very familiar with the typical PyData ecosystem, you'll probably use like pandas for data wrangling, handling. You're going to use like scikit-learn or Snowpark for machine learning model building, Streamlit for the UI. So in order to leverage the LLM functionalities to help you in data processing, Snowflake makes it easy by allowing or conferring the LLM functionality from Cortex, the pre-built one, like classify, sentiment analysis, extract answers, directly in a data frame. So you could just use apply method and then followed by the name of the function that you want to use. So in this case, it's classify text. So let's have a look at how we want to use it. So you're going to go ahead and import from snowflake.cortex. You're going to import classify text. And then for your data frame, you know that you have the name column. So you're going to use the apply method, followed by the name of the function, which is classify text. And then you want to give it some categories to start with. So you're going to tell it that for the name column, you want it to assign either of the following 2 categories. You have apparel and accessories. So for the name column, right here, it's going to read the name column, each of the value in the name column, and then it's going to assign a category of either apparel or accessories. And then we're going to do the same thing with the description column. So Cortex will read in each of these cells, and then it will assign it to one of the 2 categories that we specify here. So if you made it 5 or 10 categories or so, it will try to classify it accordingly. So let's go ahead and run it. And then for the one that uses name to categorize, it's going to be called label. And if we're using description for the classification, it's going to use the label 2 column. So shown here, so each of the row, it will be assigned a category. But then you'll notice that it also generates in a dictionary format like the key value pair, label, and accessories. So you'll be able to remove it and only specify the accessories in each of the rows here. So to do that, you're going to use the get method. And then finally, we're going to drop the label and label 2 columns. and then we're going to call it the category and category 2. So the original labels here in the dictionary format will be dropped, and then we're going to replace it with the category and category 2. Let's go ahead and run that. All right, so it's finished, and we have here the category column and also the category 2. So without the dictionary-like formatting. Let's have a look at the translate function. So similar to the previous example, we're going to use the apply method together with the translate function. And what it will do is it will translate from a particular language to another language where we specify here. So let's go ahead and run it while I explain it. So it's going to more or less translate from English to German. So we're going to have the name and description for the German language created in the new data frame or in the existing data frame. And then we're going to also generate the category and category 2 for the German language as well. So essentially, we're going to reproduce the 4 original columns into the German language. So the name, description, price, category, category 2, not the price, but then category, category 2 will all be in German. So we have here the German form, the description, the category, and the category 2 in German language. You could also replace it with other languages like in French, in Japanese, etc. Now let's perform sentiment analysis. So in a similar fashion, you're going to use apply method together with the sentiment function where you specify here. And then we're taking in the description column, and then we're going to assign it a sentiment score. More or less, this is only a product catalog description, so the sentiment generally should be positive. So if you have a look at the newly computed sentiment score, it's fairly positive. It's from a minimal value of 0.78 until 0.867. All right, and that's the sentiment score calculation. Now we're going to do summarization. So same thing, we're going to use the apply method together with the summarize function. And here we're using also the description column, and then we're going to generate a summary of the description. Let's have a look at the description summary. Here it is. So this is the summary form. Let's have a look at the original one. Okay, so you'll see that the summary is roughly a fourth or a fifth of the original version. So instead of having to do it manually, you'll be able to do this programmatically. And now let's have a look at the extract answer. So same thing, we're using the extract answer function together with the apply method. There you go. So let's have a look at the extract answer. So for each of the name column, right here, the name column, we're going to ask the question, what product is being mentioned? And then it will generate a product column, and it will provide the answer here in the product cells. So we have alpine ski, which product is being mentioned, skis. Which one? Thermal gloves. This one is specified as thermal gloves. Okay, so I would say it's pretty good. And then we're going to do now some data pre-processing, or actually we're going to do data post-processing because we had already done all of the preliminary processing. And now that we have already used LLM to help us with generating additional columns of data, we're going to have to do some post-processing. So let's say for price, we're going to remove the $ symbol. For this, we're going to use the regex, and this is just a warning. So this works, no issues here. So if you have a look at the new data frame. Let's have a look. Okay, I think we already have. Okay, we already have it. We'll call this 3. We'll call this 2. Okay, there you go. So the dollar sign, right? Price right here. So dollar sign has been removed. No more dollar sign. Okay, now we are ready to do some additional post data processing. So we're going to make sure that all of the other data columns are in the string type, except for the price and the sentiment score, because it is a numerical value, the price and the sentiment. So all else, we want to make sure that it's all strings, because oftentimes it might be an object. So let me show you. So you'll see that they're objects. And just to make sure that it's a string when we write it to a Snowflake database, we're going to have, all of the data columns as strings. So we're going to go ahead and run it. Let's do a final check. So all of them should be the string type now. Okay, so it displays as expected. Now we're going to write the data to Snowflake. So we're going to use the name of the data frame, df, and then we're going to use toSnowflake method. And then we're going to specify the name of the table, which we want to have it as avalanche underscore products. And if it exists, we're going to replace it. And then we don't want to write the index to the database. So we'll go ahead and run it. So I've already mentioned that it will write it to the database and schema that we specify early on when we create this particular notebook. So if I go to databases, I have it in Chanin demo data, and it should be in public and in the tables. And it should be in avalanche products, which is here. And here we go. Name, description, price, category, category 2. Name, description, category 2 in German, sentiment score, description, summary, and also the product. So the data table has been written. Now let's go ahead and run the data query using our SQL here. So we're going to say select all from Chanin demo data.public.avalanche products. So it's essentially the database, schema, and table. Let's go ahead and run it. And this is our data table. And let's go ahead and read it in Python. So we could use pd read Snowflake, and then it's the avalanche products. Let's go ahead and run it. Same thing. Now let's show you a Streamlit example. So in the above SQL cell here, we're calling the SQL cell here SQL read data, and we're going to use that here. And then we're going to convert it into a pandas data frame. Let's go ahead and run it. Okay, it has some could not convert string. Okay, let me try to modify this to this. Let's make it all Pythonic. Okay, so we can't use the round method, so let's take it out. Let's take the round out. No worries. So this is typical whenever we're doing data analysis, we'll always encounter some hurdles. All right, all green. There you go. It's displayed here. So we're going to have, you see, a very simple Streamlit app in about 43 lines of code. So we're essentially importing the Snowflake data table. Now we're using Streamlit to create the header text, the product category description, which is shown here. We're going to add a drop-down, which is right here. We're going to create the selected category column, st.select box, and then we're going to have the user select the category, whether it be category or category 2. And if they select category 2, it will recompute. And then you're going to see all of the underlying data refiltered and then displayed at the bottom here. And then you're going to see that we have the product sentiment analysis along with the metrics, along with the chart here. So here we have the product sentiment analysis using st.header, and then we're writing out the overall sentiment scores, and then we use the st.metric, and then we place all of the st.metric into the 4 columns where we specify here, and then we use the width columns at position index number 0 until 3 for the columns 1 through 4. Finally, we're writing out a bar chart, as you can see here. And then you'll be able to color it by the name or the sentiment score. So you see that it dynamically generates the value again. And so that's pretty much it. You'll see that we have already run this end-to-end from importing the data in, reading it in, processing the data using Cortex, performing some data post-processing, and then we've already created a simple Streamlit app as the combination project here in this tutorial. So links to additional resources are provided in this cell, and let me know in the comment section what awesome projects you're building out of this tutorial. Thank you for watching until the end of the video. If you reached this far, please drop a cloud emoji so that I know that you're the real one. And please don't forget to like, subscribe, and also turn on notifications. And until next time, happy coding!